All right, continuing the notes on covalent Lewis dot structures, we want to just kind of practice counting the number of electrons. We did that just now with this. A single bond, which is just one line, represents two shared electrons, so you could probably guess what a double bond would be. It's going to be twice as many, it'd be 4. And a triple bond would be 3 times 2 is 6. So just keeping in mind, when you see lines drawn right next to each other, that just means it's either a double or a triple bond, and they're 2 electrons apiece. All right, so let's go into how to draw Lewis structures. Turning your notes sideways, I like to kind of break these steps into something maybe a little more memorable. So the first step is our counting step, or you could say your math. We're going to do a little bit of math there, not much. Steps 2 and 3, you combine those together. That's the skeleton. Step 4, we're going to put all the remaining electrons on the outer atoms. So we're talking about outside atoms. I call them the outsiders. And then steps 5 and 6 together. No, I'm sorry, I'm getting ahead of myself. Just step 5. Step 5, putting the remaining electrons on the central atom. Remaining electrons are our leftover atoms. So this is what we do with leftovers. They go in the middle. And then we've got 6 and 7. You combine those steps together. And I call that happy with a question mark. We're asking if all of the atoms involved are happy. And then the last step only applies to ions. We'll get to that in a little bit. All right, so the first step is counting. We want to count the number of valence electrons in the molecule. So in the first example, I see that I've got phosphorus and I've got 3 hydrogens. A reminder of how to count the number of valence electrons. Group 1 has 1 valence electron, 2 is 2. Don't worry about the middle. We're not going to be dealing with the D block. But when you get over here, we've got 3, 4, 5, 6, 7, and then 8. It corresponds to the A group number. So phosphorus, being in group 5A, has 5 valence electrons. And then each hydrogen has 1, because it's in group 1. Since I have 3 of those, that's 3 times 1, that's 3. 5 plus 3 gives us 8. That's an important number. That's going to tell us how many electrons we have to work with. We have to use all 8 of them, and we can't use any more than 8. Now, if we were talking about an ion like we are over here, we need to pay attention to the overall charge. It doesn't apply here because there's no charge on this. But if there was a charge like -2 or +1 or whatever, negative ions have extra electrons, or they have more electrons. And positive ions have fewer electrons, or less electrons. All right, so then our skeleton step. That's where we're going to look at the formula. I've got pH3. You see that I only have 1 phosphorus, so the phosphorus is probably in the middle. And the 3 hydrogens surround it, pH3. Okay. We're going to connect the central atom to each of the outside atoms with a single line. That's what we call the skeleton, this part right here, pH3 with the lines connecting them. I want to remind you that each line represents 2 electrons. So if you look at this, we use 2, 4, 6 electrons. We had 8 valence electrons to work with. So 8 minus 6, that means that I've got 2 left to use. The next step is the outsiders. We always take care of our outsiders first. That means we're going to put the remaining electrons, the ones that are left over, we put them on the outside atoms first until the outside atoms have 8 valence electrons, or with our exceptions, hydrogen wants 2, beryllium wants 4, and then boron wants 6. The most important one is hydrogen. In this case, I am dealing with hydrogen, and it already has 2. This one does also, and so does that one. Each hydrogen has 2 valence electrons already. So we are not going to do that because it's already happy. Hydrogen's already got the number of electrons that it wants. If it was something else, like oxygen in this next example, we're going to put our electrons out there first until we get up to 8. Now leftovers. We still have 2. We didn't use those last 2 electrons, so where do we put them if not on the outside atoms? The leftovers get put on the central atom. Okay, so we start by putting remaining electrons on the outer atoms first, and then the leftovers go on the central atom. We have 2 leftovers, so we put those 2 dots right here on phosphorus. Now check if they're happy. Hydrogen's happy, it has 2. Phosphorus wants 2, 4, 6, 8. It has 8, it wanted 8. So it's happy. pH 3, every atom in it is happy, so we don't need to worry about this. And then it's not an ion, so we don't need to worry about that either. All right, go on to the next example. CO2. I'm sorry, it's CO3 with a -2 charge. All right, so carbon's in the middle with 3 oxygens on the outside. Let's look at our math though. Carbon has 4 valence electrons plus 3 times for oxygen. It's in group 6, so it's got 6 valence electrons. And that's all we would do normally. But this -2 charge tells me that I have extra electrons. Remember, negative ions have more electrons. It has 2 more electrons. So I'm going to have 2 extra electrons. Now we're going to add those together. 6 times 3 is 18, plus 2 makes 20, plus 4 makes 24. 24 electrons to work with. Again, we draw carbon in the middle, 3 oxygens around the outside, and connect them with a single bond. That's our skeleton. Okay. After the skeleton step, we want to put all the remaining electrons on outer atoms to complete their octet. I have 24 electrons to work with, and I've only used 2, 4, 6, so that means I can keep going. I kind of just keep counting up until I've got 2 electrons on each side of the atom. Right? I would have 2 here, 4, 6, 8. So I'm going to keep adding these electrons until I get to 24. Start on the outside until the outside each have 8 valence electrons. Because oxygen, it's not an exception, it wants 8 valence electrons. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now I used all 24 of the electrons, so that means that there are no leftovers. There are no leftovers, so that means that we're going to skip this step. The next step asks if they're happy. So if you look at CO3 with a -2 charge, if you're looking at this, you see that carbon has 2, 4, 6 electrons around it, which is not enough. It's not 8. And then oxygen, each of the oxygens is happy. So what we can do if there's an unhappy atom, or one that doesn't have enough valence electrons, is we can make a double or triple bond. in order to make the middle atom happy. The way that I look at that, the way that it works, is we'll take 2 electrons and move them down and make a line instead, make a bond instead. So this is what you would do in the step where we ask if it's happy. That's going to end up satisfying this. We're just going to draw all of the electrons that didn't move, and then we've got a double bond right here. So I've got 2, 4, and then I've got 6, 8 around that oxygen. 2, 4, 6, and then that makes 8, and then I've got 2, 4, 6, 8, and carbon has 2, 4, 6, 8. Now you can see that every atom in the molecule is happy. We're done with that part. I just did the count also. Double checked my count. And for ions only, and it says this on the next page, it says that we're going to put the Lewis structure in brackets and put a charge. This got copied a little bit strange, copied over on 2 pages when it was supposed to be just 1. So let's just say we're going to put brackets and the charge. So let's complete this structure, the very last step, and this is only because it's an ion, because we had a -2 charge at the beginning. We're going to draw brackets around it. This structure should look exactly the same as what we just drew, except for one thing. And that's the brackets and the charge. And its charge is -2, so I'm going to put a -2 right there, and that's it. So now we're done with the example problems from the notes. We'll do a couple more examples in the next video.